Today we will discuss about sludge treatment processes. So as we have discussed, wastewater is what? It is simply the used water. And wastewater may be generated by domestic or industrial sources. If we want to treat the wastewater, then basically we have four processes. One is pre-treatment, primary treatment, secondary treatment, and tertiary treatment. So when we treat the wastewater, certainly a sludge is generated, isn't it? We will get a sludge. So sludge will be in the form of some semi-solid form. For example, plastic waste, some vegetable waste, or some solids, some sediments can come. So these all which get separated from the water, which get separated by the wastewater, those all are sludge. So if we try to characterize the sludge initially, what happens? These sludge has a lot of moisture content. It may have some microorganism present on the surface of it. The volume of sludge may be more. So basically in sludge treatment, what we do, we try to reduce all these properties. So we try to reduce the total water content of the sludge. We try to reduce the volume of it. We try to minimize the microorganisms which is present on the sludge so that it can be effectively used for some other purposes. So as far as the sludge treatment process is concerned, basically these are the 6 processes which have to be adopted for sediment treatment. So the first is concentration or thickening, stabilization or digestion, conditioning, then dewatering it, volume reduction, and then we dispose it. So from all the process, what we are trying to do, we are trying to take out the water, the remaining water which is present in the sludge. We are trying to reduce the volume, and we are trying to reduce the microbial presence on the sludges. We will discuss all one by one. So first is concentration or thickening. What is the purpose of concentration? The main purpose of concentration is to remove water from the sludge. So we generally want to remove the water from the sludge and to reduce its volume. So in concentration, there are 2 processes. What we want to achieve, we want to remove water from the sludge and we reduce the volume of the sludge. This can be done, the process of concentration can be adopted by adopting any of the 3 processes. So one is gravity thickening, and there is flotation thickening, and there is centrifugation. These are the 3 methods which are generally used for concentration. Okay, gravity thickening. So from the name it is clear that we let the sludge to flow in a closed chamber, and due to the presence of gravity, the sludge will get settled on the bottom of the surface and it can be easily taken out. So the sludge which will finally come from this process, it will have some more density. That's why gravity thickening increases the solid concentration to settle at the base of a vessel, producing a concentrated solid stream. Now we will talk about flotation thickening. So we will discuss it with the help of a simple animation video. So try to understand what is this floating thickening. So in flotation thickening, what we do, we use dissolved oxygen. That dissolved oxygen, what it do? It pretend the sludge to come on the surface of the semi-fluid, and then it can get easily separated. So you can see it in the video also. So we are giving pressurized air to the system. This pressurized air system get mixed with the sludge. This dissolved air flotation, this is applied to increase the sludge solids concentration. You see these air bubbles, dissolved air flotation. So these get mixed with the sludge, and sludge is separated from it, from the top surface. So you see the top surface sludge is coming out, which is thickened from the previous. The video has been taken from YouTube. You can also go on the YouTube and you can watch it. So this is the whole process of flotation thickening. The main aim of the flotation thickening is that the sludge, which is mixed with the water, when it get passed through the dissolved oxygen, it gets separated and it gets floated in on the surface of it, and finally they get separated from it. Okay. Similarly, I am showing you a video of centrifugation. Certainly in this case, the action of centrifugal force will be used. So centrifugal thickening increases the sludge concentration by lead the particles to attract towards the walls of a rapidly rotating cylindrical vessel under the influence of centrifugal force. So you see, this is rotating through an axis, and sludge will come from that side. So sludge is coming. And when this sludge will come into this portion, there is a rotating wheel. When the sludge will pass through this rotating wheel, certainly a centrifugal force will act on it, and the sludge will get attached on the surface, on the top surface of it, and it can come out from this surface. You can watch this video on the YouTube also, which is present there from this link. So you see how this sludge gets separated. This sludge is more thicker than the previous one. Okay, now we will talk about stabilization. So after conditioning, when we have removed some water from the sludge, the process of stabilization is adopted. Why the process of stabilization is important? Because stabilization can reduce the odor which is present in the sludge, and it also reduces the further decay of the sludge. Stabilization also reduces the level of pathogenic organism. So you see all the microorganism, or all the, let us suppose, bacteria or viruses which is present on the surface of the sludge, it can get reduced by this process, stabilization. So stabilization can be done by three processes. One is aerobic and anaerobic digestion. So from the name, it is clear that if the process of stabilization will be carried out in the presence of oxygen, it will be aerobic digestion. If it will be carried out in absence of oxygen, then it is anaerobic digestion. So aerobic digestion is the process of oxidizing and decomposing the organic part of the sludge by microorganism in the presence of oxygen. Generally, it is in the presence of oxygen. And anaerobic in the absence of oxygen. What is this thermal stabilization? So if for the process of stabilization, we are using the thermal energy or the heat energy, we can say heat energy. So thermal stabilization is a heat process by which the bond water of the sludge solids is released by simply heating the sludge for a very short period of time. Chemical stabilization can be done by two processes. One is chlorine stabilization and another is lime stabilization. So chlorine, I think you know that it is also a disinfectant. So it can reduce the count of microorganisms on the surface of sludge. Lime is also used for the same purpose. Aerobic and anaerobic digestion is a part of biological stabilization. So you see, if the sludge, there are two processes. One is alkaline stabilization and there is biological stabilization. So alkaline stabilization can be done by these two processes, by using lime or by using chlorine. And biological stabilization, it can be done by using anaerobic digestion, aerobic digestion. We can also use the thermal process for it. Now we will come to sludge conditioning. So what is this sludge conditioning? So sludge conditioning is a process whereby sludge solids are treated with chemicals or various other means to prepare the sludge for dewatering process. So in this case, what happens, the extra water which is present in the sludge, it can be removed from it, isn't it? It can be done by two processes. One is chemical conditioning and another is thermal conditioning. So for chemical conditioning, we can use some of the chemicals whose name is written here. So it may be sulfuric acid, it may be chlorinated corpuscles, ferric chloride, these can be used. The addition of the chemical to the sludge lowers or raises its pH value to a point where small particles coagulate into larger ones, and the water in the sludge solids is given up most readily. So if you will ask that, what is that pH, or what is that pH value for which it can be done? So there is no fixed pH. It depends upon the sludge and a type of sludge. So from sludge to sludge, the pH value may get varied. The most frequently encountered conditioning practice is the use of ferric chloride. So basically for chemical conditioning, we are using this ferric chloride either alone or in combination with lime. Organic polymer is also used. So organic polymer coagulants and coagulant aids has been developed in the past 20 years and are rapidly gaining acceptance for sludge conditioning. So for chemical conditioning, we use some of the well-known chemicals. So we can use ferric chloride, we can use coagulants, organic polymer coagulants we can use. What they do generally, they generally stabilize this pH value so that the process of coagulation can get increased. Thermal conditioning, from the name it is clear. So if we will use the thermal energy or heat energy. So thermal conditioning is used for pre-treatment of sludge in advance of thickening and dewatering process. When the organic sludge is heated, heat causes water to escape from the sludge. Thermal treatment systems release water that is bound within the cell structure of the sludge and thereby improves the dewatering and thickening characteristic of the sludge. So basically, this is the heat energy which is doing all the process. Now, there are many methods for dewatering. The thickening and dewatering process both provide a concentrated, concentrated product retaining most of the solids from the original sludge. So so vacuum filtration is one of the method, pressure filtration, centrifugation, drying beds, and sludge lagoons. We will discuss all one by one. These are the process by which dewatering, that means removal of the water from the sludge. Why we want to remove the water from the sludge? Because if the moisture will get retained into the sludge, it cannot be used further, or the life of sludge which we are going to use for some purpose, that will be reduced. So you can get an example from here, you can relate. Let us suppose if you are taking the grain from the field, you are trying to reduce the water moisture content of the grain for longer storage, isn't it? Similarly, you think about the sludge. If the sludge will contain too much water, it cannot be stored or it cannot be used for another purpose. That's why the process of dewatering is very important. Different industry use different processes for dewatering, and these are the process one industry can adopt, whether he can adopt the vacuum filtration, pressure filtration, centrifugation, based upon the density or the type of sludge which is present. So vacuum infiltration for dewatering sludge is a drum over which is laid the filtering medium consisting of a cloth of cotton, it may be wool, it may be fiberglasses, plastic, it may be stainless steel. These are used. So on the drum it is used, isn't it? We will discuss some of it only. So we will discuss about the pressure filtration, how the pressure. So whenever, let us suppose if you have sludge, if you will try to pressurize it, what will happen? If there is some water present in it, the water will get out from it. And the simple process you can see here also in this video. This is simple pressure filtration. That means you have to apply pressure on the sludge. When you will apply pressure on the sludge, what will happen? The extra water which is present in the sludge, it will get out and the solid sludge will get separated from it. So this is simply, at this stage, the sludge is coming. The sludge is coming into the system. Now you see, since the process has, this sludge has gone through some of the previous process also. So this sludge is thick. Ye already thick ho chuka hai. But we want to make it more thick. That means we want to dewater it. So you see, this is the pressure. This is exerting pressure on the sludge and the extra water is coming out. You see the extra water is coming out and the final sludge is get converted into this form and it is going somewhere else. So you see the sludge is coming and it is going out as a seed, something like a seed. So pressure filtration is, what is this? This is one of the process to increase the solid content or to remove the dewatering process. This is one of the dewatering. You see the solid sludge is coming, which may be termed as compost or something like this. So this is the process of pressure filtration. Now we will discuss about drying beds. So drying beds, in what we do in drying beds, simply In this case, the sludge is sprayed on open ground. So you can see it is sprayed on the open ground. And there is some initial design which has been done for dewatering it by using the dry beds. So this dewater cake will be on the top layer, and then there will be some sand layer, and on the bottom there will be gravel. The extra water, with time, it can come into this system, or you can say it can get filtered, and it can be drained out from this draining pipe. But this drying bed will be always in the open. It will always be in open. So sludge drying beds provide sludge dewatering by allowing the liquid to both drain under gravity through a permeable medium on which the sludge seats. So this is the permeable medium you can see. This is the permeable medium of sand and gravel upon which you are spreading the whole sludge, and with time the extra water which is present in the sludge, it can come out through this drainage pipe in the influence of gravity. One is sludge lagoons. So what is the difference between these two? So sludge lagoon is also sprayed on the open ground, but in this case dewatering process, maximum dewatering process, will only take place from evaporation. So in sludge lagoon, we do not have this type of arrangement. We do not use impermeable layer of sand or gravels. We only sprayed the whole sludge on the open ground. So you can see the sludges are sprayed, and it will only get separated or thickened by the process of evaporation. Here, the process of evaporation and the infiltration both will act in drying bed, but in sludge lagoons, only the process of evaporation will dominate, isn't it? So lagoons are nothing but excavated areas in which digested sludge is allowed to drain and dry over a period of months or even a year or more. So once we got dewatered sludge, our next step is to reduce its volume. Reduce its volume, isn't it? So volume reduction is also important. So volume reduction can be done by two processes. One is incineration and another is wet air oxidation. So what is this incineration? This is simply combustion, isn't it? Combustion. And generally the temperature which is used, it is 1250 Fahrenheit up to 1400 Fahrenheit. It is used. All types of sludges, whether it is primary, secondary, raw or digested sludge, may be dried and burned. Raw primary sludge with about 70% volatile solids contains about 7,800 BTU per pound of dry solids, and when combustion is once started with, it will burn without supplementary fuel. In fact, an excess of heat is usually available. So in this way, the incineration process reduces the volume. Wet oxidation process is also used for the same purpose. Now, once the sludge is dewatered and the reduction of volume has been taken place, then our next step is to dispose it. Isn't it? Disposal is also important. So the sludge may contain some toxic substances. The sludge may contain some hazardous type of substances. So its disposal is very important. Where you are going to dispose that sludge? You are going to dispose that sludge in the water, or you are going to dispose that sludge into on the land. If you are disposing the sludge on the land, so basically there may be 2 or 3 processes by which it can be done. So one process is that you bury it under the ground, or you fill it. So let us suppose landfill sites. Landfill sites may be used for sludge disposal. And as far as the water is concerned, the sludge cannot be dumped into some river, pond. So fresh water sources, it cannot be dumped. Why? Because if the sludge will get disposed in fresh water sources, it can contaminate the whole water. And it will create a lot of problem for the all the living beings to drink or to use that polluted water. So in most of the cases, the sludge, if we want to dispose in water, then it can be disposed in the oceans. It can be disposed in the oceans, basically, isn't it? So in today's class, we have seen about the sludge. When after the wastewater treatment, when the wastewater treatment process will go on, certainly the sludge will be created, and that sludge should go from extra some processes. We have discussed about all the processes today, and that's for today. Okay.